Hello guys, welcome to my YouTube channel. So today we will be solving Codeforces round 909 div 3 problem D Yarik and musical instrument. Okay, pause the video, read the question and then we will proceed. Cool. So the question says there is a character called Yarik and he likes to make notes as in musical notes. So and whenever he make a note, it is of the form 2 to the power k. Okay, or simplifying the question, what the question says is there will be a person Yarik. Just a second. Ah. So there will be a person Yarik. He make numbers or note such that whatever note he will make, let's say he make a note A, then it will be of form 2 to the power k, or like the any note will be of some power of 2. Okay, so he can make like let's say note A1, A2, A3 till AN. So he can make as many note as he want. Now, what he needs to do is he needs to produce music. So let's say it's like keystroke. So one note is one keystroke, another note is another keystroke. So he will to produce some music, he'll have to combine two notes. So if you'll see the example, so like let's say if there is one note A and another note B, we already know that this note should be of form 2 to the power k. So consider that let's say A was 2 to the power k and B was 2 to the power L. So the note will be nothing but A to the power B. So what the question says? So let's say if he produced a note A which is 2 to the power k. Okay, and he produced a note B which is let's say 2 to the power L. So the music he can produce using these two notes or the combination of these two notes will be nothing but let's denote it by A and B, and that will be A to the power B. Okay, that's one thing. Now moving forward, the question says that yeah, it's just one example. There is one example. Okay, if you'll see over here, let's go through this example as well. So if you'll see, A is nothing but 2 to the power 3 and B is 4, that is equals to 2 to the power 8, and B is equals to 2 to the power 2. It was 4, right? So the combination of A and B will be nothing but something like this: 2 to the power 3 whole power 2 to the power 2. Okay, we'll come to this later. Now what the question says is, question further says that now he has produces n notes, and instead of storing them as, so let's say what he is saying that he has produced n notes a1 a2 till an. Now ideally we know that it should be some power of k, right? Or sorry, some power of 2. So instead of giving the total value, it is given the value k, or more specifically what a1 a2 an represent the power of 2 for each node. So the first node will be, let's say if a1 a2 till an is something like this, like 3 2 and the 7, that means the actual node produced over here would be 2 to the power 3. Here it will be 2 to the power 2, here it will be 2 to the power 7. So we are given this power. Okay, now, finally, the question says that in this out of all these nodes, he can choose any two nodes and make a pair, right? Now, he have to tell the number of combinations such that if he chooses two nodes, so if he chooses let's say I and J, so out of this he chooses some two different nodes or two different values A of I and A of J. That means the actual node or the actual node, we know that it will be nothing but 2 to the power A of I, let denote it as B of I. Similarly here the node will be B of J equal to 2 to the power A of J. Now the music or the combination of these two nodes will be B of I and B of J, that will be equal to B of I to the power B of J. Now he wants to know that how many pairs are there such that combination of bi and bj is equals to combination of b of j and b of I. Here it's equal. Okay, so what does that mean? That means if we write this as b of I to the power b of j, because that's what combination means, and here it will be b of j to the power b of I. So he wants to know that how many number of indices are there such that I is less than j and this condition satisfied. Okay, to understand it better, if you want, go through, you can go with example, like you can pick all the elements all and you can see. So what will be the first approach? What will be the first approach? Now we know that we have to select two pairs I and j out of this all this a1 a2 till a of n. So what we can do? We can just simply run a loop. We can simply run a loop, right? We can simply run a loop for int I is equals to 0, I less than n, I plus plus, and we know that for gth position, let's say if there were so many positions, right? So for this we know that we can pair up with this one or this one or this one or this one, so on. So for the second for the zeroth position we have started with the first position. Similarly, for the first position we can go with second, third or fourth, because we already know that I should be lesser than j. So we can run another loop inside it for j is equals to 1, or better to write j is equals to I plus 1 till j less than n and j plus plus. Okay, here we can simply calculate the values. How can we calculate the values? We know that the b of I can be written as a to the power 2 to the power a of I, okay, and b of j can be written as a to the power 2 to the power a of j. And from here we can check if power of something like this, that b of I and b of j if is equal to what? Power of b of j comma b of I. If this is equal, we can simply increment our answer. Okay, so first of all, there are now couple of problems. Let's see over here. We will see there are a couple of problems. First one is we are running a nested loop. That means it will give O of n square solution. And seeing the constraint, we cannot have O of n square solution. Okay, that was one thing. And also, if we'll see over here, we are taking power and getting this one calculating power here as well, so it will again take log of n. So overall it will become n square log n, and we know that we cannot pass this solution. So now how can we optimize it? So if you'll notice one thing, what we are saying, that if we are selecting a and b, we want that the combination this a and b should be equal to, or the music produced by a and b should be equal to music produced by b and a. And we know that a is nothing but 2 ka power k, or sorry, here if we consider from the given index, right? So the ai, so better to text here x and y, that will be more convenient. So if x and y, we know that if we are considering ith index or jth index, okay, so we can write x as nothing but 2 to the power a of y, okay, and j as or y as 2 to the power a of j. Okay, similarly, what we can say over here is 2 to the power a of j and 2 to the power a of I. Okay, if we'll see over here, what we can write over here, we know that the combination will result in 2 to the power a of I to the whole power 2 to the power a of j. And we know that there's a mathematical property that if we have power a to the power c, okay, a to the power b to the whole power c, then we can simply multiply the powers. Okay, so following this same property, what we can write over here from this expression itself, we can simply write it is nothing but 2 to the power a of j and whole multiplied by a of I. Okay, so the left side becomes something like this. Sorry, it won't be any brackets over here, don't get confused. Similarly, on the right hand side, here it is 2 to the power a of ij, sorry, 2 to the power aj, and here it will become nothing but 2 to the power a of j multiplied by 2 to the power a of I. Now we know that we can see from here is, what we can see from here is the base is 2, right? The base is 2. Okay, so can't we write something as, if I take this as some constant c, then we can write some c to the power, or like if in general if we say that c to the power x equal to c to the power y, that that means x must be equal to y. That means x must be equal to y, or c equals to 0, or c equals to 0. Both the case can be satisfied, but we know that the definitely c cannot be 0, because in the question it is mentioned that a of I should will be start from 1 until 10 to the power 9. So we know that this c won't be 0. That means x must be equal to y. So from here we have one observation. What? That 2 to the power a of j, it's a of j, and let's write a of I here, must be equal to 2 to the power a of j multiplied by 2 to the power a of y. Okay, now here we have the condition, like when those two, a pair would be formed. Now if you would have followed me from the previous videos, we know that whenever we find something like, see here it's also I and j, and here also I and j. So what do? We try to segregate both I and j separately. Listen carefully. Whenever we find some function of I and j on the left hand side, and similar kind of function of I and j on the right hand side, we try to make this some function g of I and this some function g of j. Speaking in simpler terms, we do nothing. We try to have all the i's on the left and all the j's on the right. Okay, so all the i's on the left and all the j on the right. Okay, so if we'll do the same thing over here, what it will become? It will become nothing but a of I upon 2a of I, 2 to the power a of I, equals to a of j upon 2 to the power a of j. Or if you want to write it, you can also write it 2 to the power a of I upon a of I minus 2 to the sorry, equal to 2 to the power a of j upon a of j. So if for any two I, or for any I and j, now let's say if I am selecting any I and j, then if this condition is satisfied, that means that will make a valid pair and we can count them in our answer. Now still we have many problems. First one is, we cannot calculate this 2 to the power a of I. Why? Because if you'll see over here, a of I can go to 10 to the power 9, and we cannot store 2 to the power 10 to the power 9. At max we can store 2 to the power 64 minus 1 in positive value, right, in log. Okay, so we'll have to do something so that we don't have to store this. So we know that if x is equals to y, if we'll take log both side, then also it will remain same, right? So what we'll do the same thing, we'll take log here. So if we'll take log, so it will be nothing but 2 to the power a of I upon a of I equals to log of 2 to the power a of j upon a of j. Okay, a of j, here also a of j. And there is simple logarithmic property you might have read in your 11th, 12th, or in basic classes, that if we have log a by b, then we can write this as log of a minus log of b. This is log of b. So if we'll follow the same property, what we will do? We can write this as log of a, sorry, 2 power a of I minus log a should be equal a of I. Okay, and here it should be equal to log of 2 to the power a of j minus log of a of j. Now instead of taking simple log, if we would have taken it as log base 2, log base 2. Now why we are taking thinking of taking log base 2? Because we know that if we have something like this, log of a to the power x, then we can simply jump this x to here and it can become x log a. And now if the base is also a, then this value will become 1. So first of all, what we can do this, if this a of I can be taken forward, and if we take log base 2, so this equation or LHS will become something like this: a of I in the front, then log 2 base पे 2, okay, minus again, and this where we would have taken this log, here itself. So whenever we were taking the log, so we would have taken it on log base 2. So the entire equation will become log 2 base ai is equals to log sorry, here it will be a of j log 2 base 2 minus log 2 base a of j. Okay, so here it will become nothing but 1. Similarly here also it will become 1. So the final equation, final expression, what it will become, it will become a of I minus log 2 base a of I equals to a of j minus log 2 base a of j. Okay, so final equation comes out here. Okay, if you didn't understand, please pause the video or just go backward, watch it again. Okay, so what we got, the final equation, the final equation we have something like this. And what does it represent? That if we select some two I and j, and if that satisfy this condition, that means that is a one valid pair, one valid pair. Now we know that I will always be lesser than j. Okay, so what we can do, and also why we have segregated this like total I or total j, because for a particular index, any index, we can store this value. And going first of all, what we'll do, we will start from the right. Okay, first of all we will start from the right and we'll traverse from the left. So for this index we have stored this value, whatever we value we have. Okay, a of I minus log of a of I. Okay, so we'll have a map. Okay, let's say we'll have a map of double. Why double? Because the log value can be in points. So we can have log map of int double and int mp, and initially it will be 0 or like no values will be there. So first of all we will see how. First we will calculate its value, let's say key, and that will be nothing but we know that what, a of I minus log of a of I, and this will be on 2 base. Okay, we'll see, or it's better we can simply add map of key in our answer. What will map of key signifies? Map of key signifies how many elements are there whose value is, and whose what value, this ai minus log 2 base ai. So this value or their key is equal to this key, or their value when we calculate it will be equal to this key. That means with all the indices we can take this element and we can make a valid pair, so that we can add in answer. And after we have calculated our answer, we can increment the count of this particular key. We can increment the count of this particular key by 1. Okay, we can calculate this count of this key by 1. Okay, and similarly we can traverse from the left to right. So what will happen, for this particular index we can find all the indices which can make a valid pair, and we can simply add it to our answer. Okay, I hope this would have been clear to you. Let's go back to code once. So we have done nothing as explained. First of all, we as given the question, we have taken the input, we have made a map, we have our answer initialized to 0, and then we have calculated the key value. We know that it should be array of I minus log 2 array of I, and we calculated, or we updated our answer by adding all those elements, because we know that what we know. So let's say if this is the array, right, if this is the array, and here it was value of 5. So we will calculate what, 5 minus log 2 base 5. Let's say it comes something around 4 point something. Okay, 4.3, let's say. Here it comes 3.7, and again here it comes 3.7. That means this 3.7 can be paired up with this 3.7, and here again comes 3.7. That means this 3.7 can be paired with this 3.7 or this 3.7. And let's say here it comes 4.3. That means this 4.3 can be paired with this 4.3. And if again if we have 4.3 over here, then this 4.3 can be paired up with either this 4.3 or can this. So what we are seeing, that we are just storing nothing but the count of that particular key moving from right to left. So that's what we are doing, and we are adding that count for in our answer for that particular ith position, and we are incremented the count of that particular key, and finally printing the answer. Okay, so it's an accepted solution. I hope this you would have understand, but if you guys have any doubt, feel free to ask in the comment section. Okay, thank you guys.